Metal-Arresters is your partner for surge arresters and lightning performance. CLG Introduction. Are you familiar with current limiting gaps? CLGs are considered as line surge arresters. They are officially described in the SIGRA Technical Brochure 855 in 2021. Their main purpose is to prevent lightning-induced outages on distribution lines. Nevertheless, their technology differs from Metal-Oxide Line Surge Arresters, commonly used on transmission systems. CLGs are not resistor valve type arresters, made of silicon carbide elements in series gaps. They are not designed to protect valuable equipment in substations as power transformers. CLG's technology uses an innovative approach made of one or several arc quenching chambers. CLGs offer a follow current quenching capability that is verified in a similar way to externally gapped line arresters, e.g. LA. First CLGs applications exist since the 90s. Since then, they've been expanding in various countries and have become a popular choice for distribution networks due to their attractive life cycle costs and their capability to withstand high charge transfer ratings on unshielded overhead lines. Application versus LSA. Why are CLGs used in electrical power systems instead of Metal-Oxide Line Surge Arresters? What makes them different? Line surge arresters, including current limiting gaps, have the same objective: to prevent lightning-induced outages. They are installed on the overhead lines in parallel to the tower insulation. Although Metal-Oxide Line Surge Arresters, MOLSA, are commonly used on transmission lines, their use on distribution lines has always received moderate acceptance. A couple of reasons could explain this situation. Outages on distribution lines are not so financially critical as on transmission lines. The cost of MOLSA can slow down the initial investment. Indeed, the solutions and the experience of the manufacturers are often not very convincing for the system operators. Since most of the distribution lines are unshielded, the expected lightning charge transfer is much higher than standard QR's ratings of distribution class arresters. Isolated or impedance-neutral systems lead to high TOV stress and might exceed standard voltage ratings. Failures on MOLSA are a reality that is not addressed effectively. Failures have been reported due to sealing systems, moisture ingress resulting from flaws during the manufacturing process, or aging in operation. How does CLGs work? Let's take a closer look at CLG technology. How does it work? An arc quenching chamber is a device used to extinguish an electric arc that has been struck between two electrodes. Arc quenching chambers work by providing a path for the electrical current to flow through, which helps to dissipate the energy of the arc and extinguish it. It should not be compared with the interrupter units of the circuit breakers, which consist of an active extinction mechanism, often combined with SF6 gas or vacuum, as an insulation medium. Arc quenching chambers are static components and have this extinguishing capability by design, without any active mechanism. There are different designs that are made of one or several arc quenching chambers. Multi-chamber designs dissipate the energy of the arc by splitting it into a series of small power arcs to finally extinguish it. The single-chamber designs dissipate the energy of the arc in a different way, thanks to these two holes at the extremities of the active part that project and extinguish the arc on the horns of the insulator string. Operations and limitations. It should be noted that CLGs have usability limits regarding fault currents. Therefore, the system parameters must be taken into consideration when applying them on the line. All CLGs are certified to extinguish the following current within half a cycle. The following current interruption prevents the breaker operation and the subsequent lightning-induced outage. The current interrupting capability can reach in general up to 10 kA for some specific designs. However, large energy dissipation can be expected at interrupting the power arc in the active part, which gives limitations of following current interrupting capability and the allowable numbers of operations. Therefore, the CLG can be used for systems or locations where the prospective fault current is lower than the interrupting capability. The maximum prospective fault current depends on the distance to the power transformer, which feeds the fault point. Basically, the closer the CLG is to the transformer, the higher the current will be. It is therefore necessary to check and make sure of the minimum distance. Terms and designations. In the technical literature, you might find different terminologies. It could be confusing, but all of these terms refer to the same technology. Line lightning protection devices, LLPD, or fault current interrupting arcing horns, FCIAH, are common, but you can see that more terms can be found. Global Market Overview. As a dedicated application for distribution networks, CLG application is an established market reality. The number of CLGs worldwide is estimated to be around 3 million units, mostly on networks up to 77 kilovolts, although some applications exist beyond that. The use of CLGs has become increasingly important in the distribution network, as most manufacturers have not been able to meet all the market requirements. For more than 25 years, CLGs have been installed on overhead lines worldwide to address lightning performance. Japan. Japan has more than 25 years of experience with CLGs. They also recommend the use of CLGs as bird protection equipment. Indeed, when the conventional arcing horns of the insulator strings are replaced by CLGs, the electrical hazard for the animals is reduced, or even eliminated, because the CLGs behave as insulated horns. In Japan, LSA applications exist for 40 years. They actually claim the first installation in the history. More than 120,000 CLG units are installed today in Japan, with 9 reported failures, as per an official report from 2009. Russia. Russia is also a pioneer in this technology, with more than 20 years of experience with the first installation in 1999. China. Since the first installation in 2012 in China, the application has been already standardized. The country has more and more installations, and new manufacturers are emerging. Rest of the world. Here are some other examples of applications across the world: in Italy, Indonesia, Switzerland, and Malaysia. Interesting use case in Malaysia. Here is an interesting use case published by a Malaysian utility. LSA was installed on distribution lines, as per the IEEE 1410 guide. However, a certain number of failures has been reported due to a couple of different factors, including grounding conditions, soil resistivity, and surge arrestor requirement. CLGs have proven to be a more compelling solution for some DSOs, like in Malaysia. Summary. Thanks for watching. Visit our website or contact us for more information. www.metaresters.com. Metal-Oxide is helping the energy supply industry to meet different needs in the field of surge arresters and lightning performance improvement.